Blog Talk Radio.
Welcome to the Kentucky Waterfuel Museum webcast. The date is March 24th, and we have a very special guest tonight. It is Stephen Meyer, twin brother to the more commonly known water fuel inventor Stanley Meyer. And let's see if Stephen isn't with us. Stephen, are you there?
I'm here.
Great. Well, we have 1 hour to cover a tremendous amount of territory because this is the first real public interview that you've ever done. Isn't that true?
That's correct. This is the first one, and I decided to do it on your show. I kind of like what you've done over the years. I've been monitoring different things that you've been doing. You've come a long way, and so I'm here.
Well, I'd like to welcome you and express great appreciation for your willingness to reveal to the world your involvement in the pursuit of clean energy technology over the past, 30 years?
It's been quite some time.
Yeah. Well, why don't we go back in time then and start with your background, because people really don't know who you are and what you've done in the way of inventing, developing products for various industries and government and so on. And so your resume is quite impressive. And why don't we begin with your education? You apparently went to about 3 different universities?
That's correct. Mm-hmm. I went to Ohio State and then Peninsula College in Washington when I was in the service, and then back to Ohio State after the service, and then wound up at Franklin University going to night school, and finally graduated in engineering in 73.
Okay, and that's electrical engineering, correct?
Yeah, electronic engineering, and then I had a minor in business management, industrial management.
Okay, and so the branch of service that you were in, the military service, was the U.S. Air Force? Yes,
it was kind of funny. When Stan and I were in Ohio State right out of high school, Stan went into Air Force ROTC, and I went into the Army ROTC, and then I left after about a year and decided to join the Air Force. I went into the Air Force, and then shortly thereafter, Stan got drafted in the Army.
Isn't that funny?
Yeah, it is.
Branches of service.
And the thing that really got me was that my first squadron commander called me aside one day down in Keesler, Mississippi, and he started talking to me like he knew me, and I said, my gosh, I really don't know you. And he said, sure, you were my student up in Ohio State.
He was confusing the twins.
Yeah, oh yeah. So I told her, I said, oh, you must be talking about my brother.
Isn't that funny? That is very funny. Well, I thought it was a funny coincidence what you told me last year about how the two of you were serving in overseas, different branches of service overseas. You were both discharged and arrived at your parents' home at the same time, unbeknownst to each other.
We did. I wasn't overseas, however. I was in the Pacific Northwest, and I was 76 miles from the nearest town, so it could have been overseas.
Yeah.
But the thing was that we both got out of the service, and we showed up at our mom's doorstep exactly on the same day within an hour of each other.
I think identical twins have a lot of funny coincidences like that.
Yeah, it was funny. Stan showed up with his uniform and still had his gun in his hand. I thought that was kind of interesting. He had been up on the DMZ in Korea, and they said, you got to go down and talk to somebody. So he went down there, and they said, get on a plane, and he got on a plane and came back to the States. So
isn't that hilarious? Still had his gun strapped to his side, huh?
Yeah, well, he just had a rifle and some of his camouflage stuff, and he stuck it in the corner for a while, and then decided, well, maybe I better take it all back.
Yeah, that's funny. So in the Air Force, you did receive some recognition for your work, did you not?
I did. When I went into the service, I kind of blossomed in the service, and I saw the opportunity, and so they sent me down to a basic electronics school. I had gone down and taken all their exams, and I wanted to be a pilot and a navigator, but found out that I couldn't see and didn't have any glasses, so they let me go into ACNW, which was heavy ground radar. And so I went down to Keesler, Mississippi, and went to what they refer to as basic electronics. And then after that, I got into advanced electronics. And before I left Keesler, I got into tropospheric scatter. And so I was getting a pretty good education with the Air Force, and then went out and worked on the FPS-7 radar set out in the Pacific Northwest. And it was actually a 10 million watt radar set, and we covered the whole Pacific Northwest.
Wow.
And I got involved in ECM, which is electronic countermeasures, and at that time my ratings kept climbing, and I got up to the top 5% of the Air Force when I was there. They really wanted me to stay in, but after 4 years I decided to go back to school.
Okay, and that was a good thing because you were able to pursue studying technology that became useful as you went about your business inventing things.
It did. Well, I had already, when I was in the service there, I had advanced schooling in tropospheric scatter, and then I got involved in taking USAFE courses in the service, and I actually had done my first 2.5 years in the USAFE courses.
What are you referring to? I don't understand that expression.
USAFE is a correspondence course in the military that you get college credits for.
Uh-huh.
And it was very interesting because I got into transistor technology. When I first went into the service, everything was vacuum technology, vacuum tube technology. And the transistor had been invented, and it was just coming into being, so to speak, and the military was getting the first entry into transistor devices. And so we had a couple new pieces of equipment come in. So I went and studied all about how transistors work and the new high-tech devices, if you will. So when I got out of school, I went down to Franklin University, and I called up Dean Kelly on a Saturday, and I went down and I proficiency my first year of college on a Saturday. At that point, because of my background and what I knew.
So that meant you went into the workplace then, huh?
I'm sorry, what?
Does that mean you went into the workplace at that time?
I'm sorry. Say it again.
Is that you began your civilian career at that time, or?
Oh yeah. I went into in the college at that time. I had actually got out of the service, and I went into Ohio State University, so I went during the day. Then I went to Franklin University at night, and I did that for the first couple semesters, and then I switched to night school in Franklin University. And the point there was I was married, and I had one son, and then I had a daughter coming, so I had to go out and work and then go to school at night. So.
Okay, so you began working in, again, high technology application of electronic.
Well, yeah, exactly. My first job, after I got back into school, and I was in school for a short time, I'd taken a job repairing television sets for a Conn's jeweler down in Columbus, Ohio, and they had like 250 TV sets up on their third floor that didn't work, and so within 2 weeks or so, maybe 3, I got them all repaired, and they told me not to do any more because they couldn't find the customers. But in any case, I had bumped into a couple fellows that said they had a new company. It was called Ray Data, and I went down there and talked to them, and they had a farmhouse. They just started a company, and so we got together, and I started with them, and then we sat around trying to think out what we're going to do, and they had kind of an idea, but since I had a background with transistor technology and it was brand new, we came up with an idea of doing some building instrumentation for the analysis of rotating machinery. So we applied Fourier analysis, came up with our math models, and constructed and designed our electronics to protect machinery.
Okay, and then I noticed in your resume you mentioned Reliance Electric.
That's right. We were doing really good as Ray Data, and we had built a lot of equipment that monitored electric motors and things of that nature. And Reliance Electric came down and took a look at what we were doing, and so they decided to buy us out, which
so you
they
then
did.
worked for them.
So yeah, I came into work on Monday morning, and I found out that I was working for Reliance Electric.
And so you were doing research and development for them and process control designs, is that it?
That's exactly right. We had, our company was really small when we started. We had the kitchen of the farmhouse was sales order engineering, and then the library was the engineering office. Living room was drafting. The basement was research and development, and the garage was a hydraulic lab.
So in other words, all these tinkerers listening to this program shouldn't feel bad about working in their basements or their garages, because even Reliance Electric did that, huh?
Oh, absolutely not. I mean, Reliance Electric was a big company, and we were just a small company, but we had a technology that they recognized, and we had talent, which they recognized. And so that all culminated into building a really nice business. We eventually, they built a manufacturing building in the back, and then we actually moved away from there into a brand new facility as time went on. And we built that business from scratch all the way up to a major player in the marketplace. And then Exxon came along and bought out Reliance Electric. So I found myself working for Exxon for a while.
Isn't that funny?
Yeah.
And then what about Toledo Scale?
Toledo Scale, we actually bought out Toledo Scale. They were in Toledo, Ohio, and it was a company that produced a lot of plants, processing plants, and processes. And so we bought them out and moved them down to Columbus, Ohio, or actually Westerville, Ohio. Then we got involved in doing a lot of batching processing systems. We were designing the electronic and computer process control systems. And the computers were just coming in. I had been working on the T2, the T4 computer in the service, which was already up to 1,096 bits. And they came out with a digital equipment computer that was just starting off in a 16-bit machine. And then they came with some small processors like 4-bit, 8 bits, and then the 16. So we started out very early in the computer game.
Mm-hmm. And then Altec, is that pronounced right? Altec?
Altec was a small venture for me in a way. I had a bunch of friends. Don Cullen was one of my best friends at the time, and Don had worked with us all the way through Ray Data and into the start of Reliance, I believe. And then he broke off and with a fellow, and they started Altec. And then a few years later or so, why he offered me a position there, and I took it. And we had just gotten into the laser technology. Don had gotten about 50 patents on the laser, and it was just a toy at that time. People didn't really know what to do with it. And we came up with a triangulation system for measuring thickness of material, and then we developed laser light curtains, if you will, and we did a very simple system. We used what referred to as shadow graphics, where you just shine a light, and if you put your hands between the light and the screen, you see a shadow on the screen. And so, because laser is a coherent frequency of one frequency, we were able to adjust the optics where we could measure the diameter of wire, and we could measure the diameter of the dielectric on the wire. Then we used an XY coordinates with that technology, and we actually went into the wire and cable industry and actually helped them during a time when they had a turn down. Housing industry had turned down, and I had these very expensive laser heads. They cost about $6,000 a piece at the time, and we did not think that anybody would buy them because they were so expensive. But I went out to Rome, New York, and while I was there, I set a system up just to do some testing. I had asked them if I could. A couple fellows came out, looked what I was doing, and finally there was a couple more come out, and then finally about 4 came out, and they said, "Gee, what does this thing do?" And I said, "Well, I just figured out that you're putting on too much dielectric on your wire." And he says, "Well, we have to do that because it will short out." And I said, "Well, Actually, it's only because the wire is floating inside the coating is why you have to do that. So I said, we can control the wire and make sure it's right in the center of the wire, and then you could cut back on your dielectric. And it turned out to be a 45% savings.
Wow.
And a fellow walked me back to his stock room. He had these big barrels of granular plastic. And he says, you mean to tell me that I don't have to use 45% of this material? I said, that's correct. So I went back and I was packing up my equipment to go home, and they came out and said, where are you going with our equipment?
Yeah.
So it was kind of funny. I called up Don and I said, gee, those 2 units I brought out here to do some testing. I said, oh, gosh, I said, they won't let me take them home. And Don says, hey, you got to. I don't have any more. That's our first ones. I said, well, you better build some more.
Isn't that funny?
Yeah. So we started the radiator business, started climbing pretty good. And we took it to, I was there about 2 years, and it really launched pretty good. And then I started my own company, and in electronics and in computerization. I was very familiar now with the industry.
And that's
decided,
Aplatech?
That's Aplatech, that's
and
correct.
So how long has that been in business?
Well, it's from present all the way back to 81, I guess.
Wow. Okay.
Yeah, so it's been a long time.
And so you've noted a number of successes in the endeavors that you've had as far as technology, such things as radar systems for the government, for the Air Force, jet engines.
Did an awful lot of work with jet engines. I had designed with a team of fellows a piece of electronics that at that time they were working with frequency domain on their equipment, and I realized very quickly that the jet engines would not be protected because they accelerate so fast. So I converted everything to a time domain, and I was able to establish electronics that would do a predictive control. And so with just several points of measurement, I could actually predict where the jet was going to go. So we were able to protect it and shut it down, and that was a huge product for us.
Yeah, I think this is an interesting one here that you used in Libya to put out an oil well fire using 2 jet engines to shoot natural gas down in. And
yeah, what we did there was that when I went over to Libya and went out into the field, I went in 800 miles. If you triangulate between Benghazi and Tripoli, about 800 miles, that's where they found the oil. And the field had not been opened up at all, except that they had done some drilling. And what happened was a huge volume of natural gas was released and was being released in the air. And you can't let it go into the air, as raw gas. So they had to light it. And when they did, you could see that son of a gun 25 miles away.
It was 3 miles high, huh?
Yeah, if you look at the curvature of the Earth, for example, if you're looking straight on the Earth's surface out into space, if you go out 300 miles, you're 33,000 feet above the horizon. So if you bring that back to where we were looking at the tip of that, the height of that torch, it was about. It fluctuated between, I'd say, a mile at the low point and about maybe 2.5 or 3 at the high point.
Wow.
And it was unbelievable. So what we did was we got an idea. We said, well, why don't we take the natural gas that's coming up and run jet engines off of it, and then we would take the exhaust from the jet and push a gigantic compressor and push it right back down into the ground. So we did that, and it worked.
What an ingenious solution.
Yeah, so we were able to extinguish that torch. They called it the torch. So then they went in and they built 2 more trains after that, and we actually increased the yield of the oil field by about 10%.
Well, you have a number of other accomplishments listed here on this resume that are very impressive, and someone may be wondering, why have we just used the first 20 minutes of this interview talking about these accomplishments that have nothing to do with water fuel? Well, it's because your involvement in this technology and that of your brother have been called into question by people who really don't know the story, and they've attempted to lump you into a category of alternative energy con men, people who never really had a working product, but who tried to foist it on a gullible public and get investors. And when you type in Stanley Meyer on a word search, this fraud case comes up, and they think that the net result of all of your all's work in alternative energy was some fraud where investors got scammed and sued and won. So I think it's important.
Well, first of all, I have a sterling reputation in the industry.
Absolutely. Well,
I mean, the people don't get to be my age and have the successes that I have without that sterling reputation. And the thing is that a lot of people say a lot of things which aren't correct, and you know it's disheartening. Stan's not here to defend himself, and I, for one, look at it and I shrug my shoulders at him. I said, "Well, boy, it's amazing to me, that." And besides that, the case that I think you're talking about, where it's fraud and so forth, Stan Meyer had a contract disagreement, not a technology disagreement. And there's quite a story behind it, but in any case, they basically, the two fellows, one was sick and needed the money. He wanted to cash in, so to speak, if you will, because Stan had sold dealerships to finance what he was doing, and the other person ran into an industrial accident problem where a fellow was killed in one of his places, and he needed the money to cover the attorney fees, and I never really understood it, because essentially all they were asking for was, could they get their money back? And I would have, if it was me, I would have said, yeah, we'll just sell your dealerships and go on. But they got into some sort of a disagreement, and Stan dug in his heels, and so that's what happened.
Yeah, well, I'll just give you an example. When the local newspaper finally ran an article on my museum, after I had to badger them for 6 months, they mentioned that they dug that up off the internet and included it in the coverage of my museum on the history of water fuel.
Really? That's a shame.
I know. It just shows how there's a negative attitude toward this technology, and there's an obvious bent toward discrediting it or attempting to. And so that's why I think it's good. Because in my book on the history of this technology, one of the points I make is that if you want to know if someone's a con man, you look at their other accomplishments, because you'll get a pretty good idea whether they're competent inventors by looking at what else they've done.
Oh, absolutely.
And I think that your resume is, and like I say, we haven't even scratched the surface of some of these awesome things that you've done.
Well, talking about inventions, let me talk about my orange juice system. And the reason I want to do this is because it'll tie back into this water fuel cell deal, so to speak. And so let me just talk about that a little bit. It started when I was in high school. It was kind of interesting. I was a senior in high school, and I was taking chemistry, and I had just come out. I was doing a lot of sports and whatnot, and my class was at like 3 o'clock, and I'd come in and sit down, and the sun would be beating on the windows, so I'd go to sleep half the time in the chemistry class. And but I had to graduate, and I didn't graduate high on things. In fact, I think it was 188, and I was probably 186 or something like that. But I went to Mr. Henry and said, gee, I got to have a C out of this chemistry course to make sure I graduate. And I said, boy, is there anything I can do to ensure that I get that C? And Mr. Henry was, he was packing because he had gotten a job at Ohio State University for the next school year. And so he told me, he says, I want you to write 2 papers for me. I want you to write a paper on esters, and then I want you to write a paper on nuclear fission. Well, I went down to the library, and of course they didn't have copy machines in those days, but I just plagiarized the heck out of everything I get my hands on. And then after 3 days, I looked at what had been written and what I wrote, and I finally wrote a cover letter, and I said, Mr. Henry, I said, I can't do justice on these 2 topics. But anyway, I handed it in to him, and he gave me my C, and I graduated. But I gave him a promise that I would look into those two things further. Well, it turned out to be that Dr. Westbrook down in Florida called me up one day, and he said, "Steve, your name was given to me and some fellows in the industry, and I need some help. Would you come down and talk to me?" I said, "Sure." So I went down and talked to him, and he says, "Steve, we've been working on a project for 11 years. He says, I got to go in front of the state of legislature in the state of Florida and explain to them that I have used up $11 million and I don't have an answer." I said, "Well, Dr. Westbrook," I said, "why don't you introduce me to what your problem is?" So he introduced me and took me around to all of the different departments that he had, and they explained to me what they were trying to do. And over those 11 years, they were trying to come up with a methodology in a way to measure the quality of orange juice. And they had done a lot of things, and they were working on a refractometer methodology to do that. So I listened to everyone, and took about 3 or 4 days to do that. And then finally I said, "Well, Dr. Westbrook, I've got to head back to Ohio, but I'll look into this." And he said, "Steve, you got to do something because I've got to go in front of them probably in about 3 or 4 weeks." And I said, "Wow." So I went back, and what I did was I went into what I referred to as a think tank, and I took 2 weeks, and I looked at everything, studied everything I could. I sure wish we would have had the internet then. But in any case, after 2 weeks, I went back, and Dr. Westbrook said, "Well, Steve, what's the answer?" And I said, "Well, Dr. Westbrook," I said, "everybody's right." And of course, he was shocked at that. He said, "Well, I said, "Well, the problem is you are taking a laboratory experiment and you're trying to take it out into the real world." And I said, "You can't do it because you have to control the environment to such a high degree that you'll never get the accuracy you're looking for." So they were using 25 gallons of orange juice, and they were only extracting about 125 milliliters of that juice to do their test. And I turned around and said, "Well, why don't we use all of the 25 gallons of juice?" And I said, "If I use that, at least 5 gallons of that juice," I said, "we could get a pretty stable reading." So I came up with a methodology, and it was kind of interesting because in order to measure the degrees Brix, I had to use a plummet that was made out of stainless steel that weighed 12 pounds. And I was measuring 0.002 grams using a 12-pound weight in orange juice. And I said, I can back weigh it and get the degrees Brix. Well, the net result of all that was that I built a system, took it down, we tested it. State of Florida was only getting a 10% accuracy out of their system, and their requirements was 1%, and I was able to get 0.1%. So with that, I was able to build an industry down there. We took one, and when we were all done, we put in 74 processing plants. Our system, and then the growers in Florida are paid by the quality of their fruit, and the blends of the orange juice is controlled by the results of our testing.
Wow.
So the case in point that I want to make was that they were all right. The thing was that they needed somebody to look at it in a completely as a whole, not as an intricate part. And that's what's happening to this water fuel cell. The systems of trying to run automobiles off of using water as a fuel. And right now, I am in that same position with this. I think that I'm onto something. I think I'm starting to understand what all these inventors have been doing, what the results, and I want to pass it to them. I take my hat off to every person that has contributed to this process. It's amazing, putting your time, your energy, your focus into this thing. It's a collective kind of thing, and I just thank you because it's needed. And the fact is that people start to realize as time goes on, there's more to this than meets the eye.
Yeah, that's certainly true. Well,
let me ask you a question, James. After I've read your books, and there's something about Kentucky. Kentucky seems to be on water as a fuel. I've read your books, and there's also a Mitchell Peavy book. I don't know if you've read his book.
Yeah, it's out of Louisville. I've never met him. I don't even know if he's in Kentucky, but I know he shows a Louisville address, Fuel from Water.
Yeah, it's Louisville, Kentucky is where he's at.
Yeah, no one has been able to contact him that I know of.
Really?
People are attempted to. I don't know where he is or who he is.
It's a very good book. I've read it many times, and I've read your book, and I've been studying all the basics in the physics and the sciences, trying to understand this technology. And I worked with Stan back when he first started, but I was doing my own thing, raising my kids and going to school, and then I had my own job. But I'd go down every once in a while and work with him. And I remember there was a case one time when he was trying to run an automobile, and I came down, and he had this great big, what I call big Bertha. It was sitting in a garage, and they had produced the gases, and they had a hose going up into the carburetor, and it was like a 1/4 inch or an 1/8 inch copper tubing, I think it was, and they were trying to push it down into the carburetor of the car and try to run it, and they weren't having too much success with it, but there was a moment where they kind of got away from it, and I picked up the unit, and what I did was I got a glass jar and filled it up with water, and then I turned the gas to go through the water so it would bubble, and I would create these bubbles, and I said, I just want to prove to myself what he had, and I put a lid of wooden splint, and as the bubble would come up to the surface while it hit that wood splint and it was on fire, it would just explode. It was like a M80 firecracker. And of course they all came back and said, what are you doing? I said, well, I wanted to see just how much energy was in this bubble. So I was able to size from the bubble. I said, well, you're putting way too much stuff into the engine. I said, you got to cut it back. So those kind of things, those events that I would come down from time to time with Stan, and I would make some contribution to something when I was there, but then I would leave. But he certainly stayed with it, I'll tell you. He put his heart and soul in it.
You hadn't been involved in any alternative energy technology early on. In your earlier work, you never had anything to do with energy systems.
Well, my systems were jet engines and energy from the fuel. We use kerosene and natural gas and those kind of products to run jet engines, and that's where my...
Now, Stan was interested not only in finding an efficient way to decompose water for fuel, but also he was interested in showing that it could be applied to everything, from jet engines to home heating to power generation to just running cars down the road.
Yes, he was, because as time went on, Stan and I talked about things, and we were learning and talking about things, and then we could see, we started to get a sense and a feel that there was more to this, that there's more to this process. We started to see a tremendous amount of energy available. If you go into if you look at the organic chemistry, you start to look at the breaking of the bonds, and you start looking at the ionic bonding and the valence bonding, and then you start looking at how the combustion process works, and then you start looking at the atoms, and that's a point I want to make, that I hear these things like over unity, and I hear things like perpetual motion, and people use them quite indiscriminately and really in the wrong context. And let me give you a case in point. perpetual motion. I hear this word perpetual motion. But originally what happened was when they were developing the microscope and they were increasing the magnification, and as all new inventions, the magnification gets better and better and better. And what happened was they were using pollen. And we can't see pollen; it's so small. But they were putting pollen into a drop of water, and when they were doing the magnification, they saw that the pollen was always moving. And so every time they went back, they said, well, it's perpetual motion. It's moving. So they went to Einstein, and so and asked Einstein, says, what's causing the motion? Is it the pollen causing the motion, or is it the water? And so Einstein said, he looked at it and studied it and came back and says, well, the water is what's pushing around the pollen. Well, there was a spin-off from that because Einstein was able to determine the size of the water molecule. So that's the key what perpetual motion is. Now, when you come to over-unity devices, that's another terminology that people definitely are not using correctly. If you look at, if you took a piece of paper and you drew the x-axis and the y-axis and you go down into the lower left-hand corner and you start drawing an exponential curve, if you draw at the very lower corner area, you could draw and say, okay, that's where we look at what I call linear functions of our universe. When you look at what's in motion stays in motion and so forth. With Newton's law, but then again, if you continue on the way up in the exponential curve, you can go up to, let's say, 3-4 inches on the page, and you get to the top of the exponential curve, and that's where Einstein realized and was able to derive from the equations. He is able to derive and determine that E is equal to mc squared. Now, the point in case is that it was Einstein's work with photon energy that he discovered and realized that mass can change into energy, and energy can change back into mass, which is huge amounts of energy. Now, that the energy is locked in every atom, and it is locked in because in the universe you have hydrogen and you have helium in the universe, and then when the stars explode, when a supernova explodes, it actually is so much energy, and the temperature is up in the trillions of degrees. The elements are formed. All of our elements are formed at that time, and when that happens, it stores a huge amount of energy. And so Einstein realized that these atoms have a huge amount of energy. Well, when you look at combustion in an automobile engine, the combustion process only uses 1/millionth of its mass energy. Only 1/millionth of its mass energy. So if you did something, you add these products, the hydrogen and oxygen, to this process of combustion, and you get a little more energy out, all you're doing is basically converting a little more of that mass energy. That's where it's coming from. So when people say you got over unity, they'll realize how much energy those atoms have. So you have valent bond energy, you have ionic bond energy, and you also have a mass change energy that you're dealing with combustion. And
now, am I to understand that as this research on the part of you and your brother went on, it began simply breaking those basic bonds, but you ended up getting into something more like nuclear energy. Is that so?
Well, what happens is you start to cross into areas that all of a sudden you become aware of, and you can go back and you look at Stan's process, and for example, a good one is that Stan always demonstrated. He would turn on a cell and produce this gas. He would produce a flame. Now, when he was doing that, Stan had some visitors from Europe. He had a Dr. Lawton and a Dr. Dr. Henley, and he also had Admiral Griffith that would show up, and they showed up at his lab one day, and I was there. They had just visited different places in the United States and came over to see Stan and heard what he was doing, and so Stan lit this flame. Well, Dr. London didn't see the flame, so he put his hand over the top of it, and Stan tried to stop him from doing that, but it was too late. He already burned his hands, and their mouths just dropped because he says, "My God, we can't see the flame." And so Dr. Henley, who was an authority on hydrogen, said, "Well, it's the purest flame I've ever seen." And if you look at a Bunsen burner or you look at the Brown's gas, you can see the different colors, the greenish and the bluish colors, which show that there's a breaking down of the molecules of the elements within that device. And Stan's device was so clear you couldn't see it. Well, if you look at Stan's video, I tell the world here, you know, that when he puts that paperclip into that flame, I want you to look at those sparklers. And those sparklers that are coming off, you'll notice that they go up a certain distance and then they split. There's symmetry in that split. What you see there is, in reality, is the plus or minus Z bosons of the atoms. And one of the scientists that came and visited Stan saw that, took a picture of it, took it back, and came back and said, "Stan, do you know what you have?" And Stan says, "I don't know. What do I got?" Well, he told him what he had. And the scientists back in those days were just discovering that some of these sparklers and things were starting to show the elements within the atom. Huh. So yes, there is a powerful amount of energy that it is evolving, and it's a relationship. And that's the point. Another point I want to make is that it's not. You break the elements down to the hydrogen and oxygen, but you know that's not how nature works. The molecules in water actually have seven. Not there's covalent bonding, but there's also ionic bonding, and there's seven bondings to each molecule framing, if you will, if I can put it that way. But the ability of the water molecule is not like any other compound. You know, the hydrogen, oxygen, it's what I want to say. The distance between the hydrogen and oxygen is the longest distance of any compound that we have. So it has a compound condition. It's also bipolar, which means that the influence between the charges between the hydrogen and the oxygen is such that it has a charge on it. So it's very important when you start looking at the molecules. Then you have to look at everything else associated with it to understand it. And that's what I've been doing for the last 9 years since Stan passed away. In fact, he passed away this month.
Oh, yeah.
I think it was the 17th, I think it was. But in any case, I've been trying to understand what this technology is, and I think I'm at the same point that I was on the orange juice system. I look at everything that people's been doing, and by God, they're all right. The only thing is they haven't found the connection, and I think I have.
Yeah, well, I think that's certainly true that many people have obtained results without really knowing why or how or even what they're producing, you know. And it seems that Andrew McCroskey's reference to Brown's gas or the oxyhydrogen gas coming out of an electrolysis system as a soup, and every soup is unique. And it seems that we need to come up with some system for classifying all the different types of gases that come out of these chambers, because they're not the same.
Oh no, it's the configuration of the device and the elements that you're using in the device, and it's how you're applying the signal, all of which is important.
Yeah, there are a lot of factors influencing the net result.
the thing really that comes out to me is that when you look at the prime movers of the atoms, of the electrons, and you go back and like J.J. Thomson when he discovered electrons and so forth, that the prime mover for electrons is voltage. And you can speed that rascal up, and they're doing it with these cyclotrons up to 1 million electron volts. They'll move. And then as you move down a ways where you bump into the heat, you bump into chemistry. And of course, chemistry is all heat. That's what it is. It's you either get it hot or you cool it. That's what chemistry is. But before you bump into chemistry, you're into chargers. You're into the electrical aspects of things. And that's what made Stan's invention so important. All of a sudden, they saw a different thing. They saw more gas coming out. They saw a pure gas coming out. And so I kind of laugh at the people that, that discount him, that say all these things that, of course, he's not here to defend himself. But I look at it and say, well, okay.
Well, and just to touch briefly on his own accomplishments, he was an accomplished inventor prior to his endeavoring to perfect a water fuel cell, right?
Oh yeah. Stan worked for Patel Institute before he went after this. And I remember the first time Stan showed me this process of hydrogen. I had gone down there on a Saturday just to visit, and he got out a coffee cup and he put some water in it, and he took us these two little probes and he put the probes in the water, and I saw this little bit of bubbles come up, and he says, "That's hydrogen. That's hydrogen." And Stan and I always had a good relationship. I never told Stan that it would never work at all, and I could put on my educated blinders and say, "Stan, that's just bubbles, But I didn't, and as time went on, he actually kept showing me, and then pretty soon, after about 3 years, I was convinced.
Yeah. So how would you summarize the success of his early achievements? Would you say it was a matter of a simple? I mean, the other day I was interviewing Willard Elliott, and he said, well, he could drop a couple nickels in some water with washing powder and do some cold fusion. Would you say that Stan's success had to do with winding coils? Does it get down to just wrapping copper wire or what?
Oh no, Stan's success was the running of his automobile. Once you do something, you say, what are you going to do with it? And his success was actually going out and running that automobile. And the guys I worked with in Charles Holbrick and Stan Grummet and Matthias from Norway, the guys that work with him, they really were excited and they worked very hard. And Stan had done something that at that time that really nobody had really done, and he had taken videos of a lot of his work and stuff, and he was very excited that he was able to do that.
But there was no way to bring it to market or able to there's no way to implement it for the good of the planet as far as pollution and...
Well, he died.
But I mean...
he never got a chance to finish it.
When that first video hit the news program in 1984, I believe it was, that's when the Grove City News first reported on the dune buggy running down the road. There was 14 years before he actually passed away. So the question is, why didn't... What happens to a public demonstration of a technology back then that causes it to not come to fruition in any kind of marketed device any sooner? Is it because gasoline was still cheap, or?
Yeah, but we'd gone through the oil embargo of I think it was 73 and 74, and there was a lot of interest, and that's why he did it. He said, "Hey, I think I could solve this problem." And then after the prices went back down, nobody could care less. And he would talk to people and say, "This is what I'm doing," and nobody could. The phone quit ringing, and that was it. So he spent his time doing research, and that's what he loved, and he wanted to advance as much as he could, advance the technology as much as he could. and that's what he did.
Yeah, it's not easy to stick with the project when the public loses interest in it.
Well, it's a financials kind of thing, you know. So Stan was not a wealthy man, and he lived in above a two-car garage, which was his lab, and one side was started off to be a automobile stall where he made his office, and then he got a hold of the stall right next to it, and that's where he brought in the car, and he worked like 24 hours a day to make all that happen.
Mm-hmm.
And
now, recently you've been working to try to bring about something that would actually be usable. For instance, you copyrighted, I don't know if you patented this, but I did see where you had copyrighted a document for a hydroxyl filling station.
I actually found that patent.
That is patented now.
Yeah, well, it's not patented, but it's in the
application process.
It's been published, as they say.
Okay.
Yeah.
And so, what would be the purpose of that invention? That would enable filling stations that currently have underground gasoline tanks to have instead underground water storage tanks, and produce the hydrogen oxygen fuel for people as they stick the nozzle in their compressed hydrogen tanks on board.
Exactly. It's a system I put together that can go into three main areas. One, the concept is if a person bought a hydrogen car, such as a fuel cell vehicle, they could put this device in their garage and create the hydrogen that they need to run that vehicle with. The other one is in your home, or you can scale it up for the hydrogen highway. The hydrogen highway is where they're going to put these filling stations along the way where people that buy these cars can fill up. So they're going to develop hydrogen highways to start with. So it's a local type of installation. And then the third application that we're going after right now is the windmill generation of hydrogen. Because the windmills are variable speed, and sometimes they only run about a third of the time, what they want to do is create the hydrogen and then push the hydrogen down into the ground, and then on off-peak times bring the hydrogen back up and run generators to generate electricity from that hydrogen. So that's how they're going to do it.
Okay. So in the case of of all three of these units, you're using something like the water fuel cell to do the decomposition of the water.
My methodology is far advanced than what Stan's was. I went back to square one and did the research over the last 9 years to understand what is really happening. And so I finally got to a point that I found my patent on it, and it's a magnitude over what Stan was doing.
And so how would you summarize it in a sentence or two to a layman? How could you describe the way water is decomposed in this improved version?
My goodness.
Is it doable?
Huh? What?
Is it doable?
Well, of course it is. You can't get a patent on something that doesn't work.
I mean, how are you breaking the bonds? Are you using electromagnetic field, or?
It's part of it. Let me put it this way. When people look at basically look at an oscilloscope and they look at a signal, they don't realize that signal that they're seeing on that oscilloscope is a representation of actually what's happening in that device or in that component. Let me give you a case in point. Let's see. I think it was Maxwell. Where Maxwell, when he was doing his studying on the magnetics, that was all brand new. He had taken a bowl and he put mercury in the bottom of this pole, and then he took a permanent magnet, which was a cylinder, and he stood that cylinder upright in that bowl. And then what he did was he hung a wire above that magnet, and then he put another wire which had a swivel on it, and he pushed that wire down into the mercury, and that wire started rotating around that magnet. So he, in effect, discovered an electric motor, but he didn't know it. But the thing that people don't see, and this is the point I want to make with my research, is that when the current flows down the wire, it rotates down the wire. It's not the concept where it pushes into one end and pumps out the other. It actually rotates down the wire. So if you take your hand and you extend your thumb upright and your forefinger forward, and then the third finger at 90-degree angles, that's the relationship between voltage and magnetics. And then if you take your hand and you spin your hand, that's the way it travels. It spins. And so that's an important part. So what I'm saying is that when you look at these devices, I look at them differently than just the distance between the plates. I look at it from the aspects of everything involved in that device and trying to explain. And I listen to the inventors and I read what they say, and I try to understand from my point of view what they're really saying.
Now,
and
which inventor has proved to be most helpful to you in looking at things in a fresh light? Which are the many inventors that you've reviewed their work? Can you name one that you would say has been more insightful into?
I can't. I really can't. And the reason for that is that when I look at these inventions and that people's doing and so forth, every one of them is making a contribution.
Yeah.
And I can't put my finger on and say, this guy is better than this other guy, because what happens is I start looking at what it was that they were trying to accomplish. And so when I look at these things, I'm looking at it with a different point of view. And let me explain what I mean by that. When you look at the contributions of Einstein, and Einstein, he proved the point that you can take 2 pounds of U-235 and 2 pounds of U-238, you put them together, and you get this massive explosion. He answered a question about over unity power. I mean, it's unbelievable. Now, but what I'm looking at is I'm looking at infinity, and infinity is where the answer is today. We start off linear. Over the last 500 years, we've been dealing with linear functions. Einstein come along and says we're looking at exponential functions, and today we're looking at I'm looking at infinity, and you have to. And looking at infinity, it opens up the doors of what's really happening, and particularly in combustion. It opens up so many doors of understanding of what combustion really is.
Yeah, and I'm infinity with regard to our time, and unfortunately we're down to our last 2 minutes.
Okay, let me just make one point, one point. Okay, it's very unusual that you start with a product, you use a product, and you end up with a product, but I want to mention something about automobiles. They got a new hydrogen industry, and cars, as you know, always have run off of hydrogen. From my studies, cars have always run off of water. Interesting statement. Very interesting.
Well, I know the first car did.
Yep.
Way back then.
Effectively, from my point of view, they all run off of water. That'll be for another good program.
Well, no, it's certainly true that water does come out the exhaust of every car.
No. You have to look at the reaction of combustion to understand.
Inside combustion. Okay. Well,
you have to look at the chain reaction.
You're right. We will have to take this up in another program. So why don't we do this? Why don't we say goodbye, but keep in touch? And what would you say to doing another show where we can get into more of the theory behind this?
Yeah, I'd like to do that.
Okay.
I'd like to do
Well, listen, I sure appreciate your helping to establish the veracity of what the Meyer twins have done over the last 30 years in behalf of mankind's enlightenment with regard to alternative energy. And I know there's a lot of other good products, even dealing with orange juice, that you've brought about thanks to your ingenuity and your research and your efforts. But again, thanks for joining us, and we will look forward to picking this conversation up in the future.
If you're going to make an addition to your book, send me a copy, will you?
I will.
All right. Appreciate it.
Thanks for joining us.
You're welcome.
Appreciate it. And Tune in next week for more on this interesting story.